Thank you for joining the live class that is about to start now. If you haven't subscribed to the channel, please do us a great deal of good to click the subscribe button, endeavor to turn on your notification button to ensure that you get notified whenever we go live or whenever we drop videos on our channel. Okay, so thank you for your patronage. Thank you for watching all our videos. Please do well to share our videos, give your good comments, and endeavor to like our videos. Thank you very much. So the question is, what shall we be doing in today's class? Today's live class is still on functions of a real variable, and we will be continuing our Q&A series. Okay, so in yesterday's live class, we took our very first Q&A series on functions of a real variable. In today's class, we shall continue from what we did yesterday, where we stopped yesterday, by taking more Q&A questions. This time around, questions probably on the inverse functions and its applications, questions on the composite functions, and more complicated questions on functions of a real variable. So if you are here on the channel watching this video live, take a seat, look for something good, a soft drink probably, and join the class. So welcome to GER Hub. Let us begin. In today's class, we have several questions. I would want you to pay attention and endeavor to give your good comments, ask questions when you need to. Remember, it's an interactive class, it's a live class, so your questions will be observed and your questions will be attended to. So let's begin. Now, I'm going to start with today's question 1, okay? I'm going to start with today's question 1. I hope what I'm writing on the board is very clear enough for you to see. So question 1, without waste of time, says, find the largest domain, of each of the following mappings. Now, I remember clearly that in yesterday's class, I gave an assignment, I gave an assessment to you guys, a task for you to complete after our class of yesterday. I want to believe that most of my students or most of you who watched the video happen to have done that assignment. I hope you did them. Please give me your results in the comment section after this class. I would love to see them. So we shall be looking at these questions, and I'll be giving you some of them. I'll be taking some, but we'll be giving you others to look at. So I'm writing out the questions for today. You have D, we have question H is a mapping from X into 1 plus X over X squared minus X minus 6, and E finally is a mapping that takes from an element X and assigns to it an element 2X minus 3 all over X. Now, please take note, guys. I'll be choosing at random. I'll be solving these questions at random. Now, the essence of this class, mind you, is not just about solving problems. It is to equip you with techniques for solving problems. It is to equip you with the knowledge on why questions are set the way they are set and how they should be answered. So we are going to take our time to diagnose problems and give analytical solutions to them, okay? So in today's class, our question 1 reads, find the largest domain of each of the following mappings. And question 1a, we have in question 1a we have a mapping. In question 1b we have another mapping G. We have a mapping F. In question C1c, in 1d we have a mapping H, and in 1e we have another mapping F. All of them exhibiting or describing different relations, different mappings, different functions. So, what is the interest of these questions? The task is simple. We are to obtain the domain, or rather to specify the domain. So the most or the proper language is to specify the domain. Now, let's come over here for solutions to this. Now, should you be given these tags in your exam? Should you be given these tags in your assessment. The question is, what does the question really mean? So what do they mean when you are asked, or when they ask you for the domain of these functions? So I'm going to take your mind quickly to number systems. Just in case you're not familiar with number systems, you can find videos on different number systems on my channel. So let's pause a little bit and go to number systems, because number systems will help you understand what to do here. Okay? Now, there are basically several number systems you should take note of. So numbers are subdivided into two categories. So if something is a number, it means it is either a real number or denoted by this type of R, or it is a complex number. So once a thing is a number, it will fall certainly under either of two categories. Either it falls under real numbers, or it falls under what we call complex numbers, denoted by this type of C, a C with a stroke. Okay? Then, when something is called a real number, it means that number called a real number is either rational, denoted by this type of Q, a Q with a double stroke, or irrational, in which case you could denote your irrational number system by this type of F. Okay? Now, if a number is a real number, it is either rational or irrational. And if a number is rational, it means that that number could have been an integer, denoted by this symbol Z, this type of Z, okay, conventionally. Now, if a number is an integer, it means that number could be a positive integer, denoted by Z plus, or it could be a negative integer, Z minus. Now, positive integers are usually referred to as whole numbers, otherwise called natural numbers. Okay? So positive integers are whole numbers, or called rational numbers, and they are denoted by this type of N, conventionally all over the world. So I want you, this is just a quick diagrammatic structure of numbers. I'm not going to dwell on irrational numbers, because when numbers are irrational, they could be transcendental or algebraic. And I'm not going to dwell on complex numbers, because when a number is complex, please take note, it means that it is made up of two parts. A part A, called the whole number part, and a part B, called the imaginary part. So there is a part here that has IB, called the imaginary part. And in this imaginary part of what is called a complex number, please denoted by a strict Z. In this imaginary part of a complex number, please take note, the imaginary part is made up of I and B. The B there is a real number, and the I is called an imaginary unit. Now, why is it necessary that solving question 1 would require a good knowledge of number systems? It is because if you do not know numbers, if you don't have at least a surface level knowledge of numbers, it will be very difficult for you to attempt solving certain questions in mappings or functions of a real variable. Now, having said this, another thing I'm going to say before we go straight into solving that problem is this. Please take note. In each of these number systems, remember, numbers are split into two different groups or categories, real numbers or complex numbers. Every number system known to man, it has a symbol that is used conventionally for representing them. You must know those symbols. So when questions are given to you in mappings or functions of a real variable, they will be giving you those questions alongside symbols representing number systems. And it becomes difficult for the student who is not familiar with number systems to start having an understanding of what those symbols mean. So those symbols are conventional, meaning that in every part of the world, it is accepted in mathematics to a large extent that such number system should be represented with those symbols. So you need to know those symbols that represent the number systems, and you need to also know that every number system known to man has a set of numbers that can be found in them. Now, before we move on to solving that problem, please let me summarize this diagram with telling you what numbers are real. If a number is real, it means it is not complex. If a number is real, it means that number could be rational or irrational. Now let's start in explaining real numbers. Let's start from the bottom. Okay? So what we have at the bottom of the food chain under real numbers is the natural number system denoted by this type of n. I hope you can see clearly. Good. So this type of n represents natural number system, and the natural number system can otherwise be called the whole number system to a certain extent. The natural number system, the question now is, guys, what kind of numbers can one find in the natural number systems? Please, there is another symbol that represents the natural number system. It is called the symbol Aleph. Aleph is this symbol, just in case you don't see the type of n I had put there. There is another symbol called Aleph. Okay? So Aleph, some mathematicians use Aleph to represent numbers and the natural number system. Now, there are two types of natural number systems. There is an existing argument in mathematics that natural numbers should start with 0, meaning that 0 should be regarded as a natural number, and there is another group of mathematicians that believe that 0 is not a natural number. Okay? Now, if you are talking about a set of natural numbers that includes 0, we often will put this as, that number system will be denoted by this or Aleph null. Okay? When you see Aleph null, or you see this type of n with a 0 at the bottom, it means the natural number system being discussed is one that contains 0, that recognizes 0 as a natural number. When you see Aleph 1, or you see this n with the 1 at the subscript as a subscript, it means the natural number system being discussed excludes 0, does not recognize 0 as a natural number. So, be that as it may, please take note. Natural numbers are regarded as whole numbers, meaning that in what's called the natural number system, there are no fractions, there are no decimals, there are no negative numbers. All you have are whole numbers. They are called natural numbers because we use them in our daily activities for counting and grouping objects. Okay? Now, so at the bottom of real numbers is the natural numbers. Now, it means you must know every natural number is a real number. So 1 is a real number, 2 is a real number, 5 is a real number, 100 is a real number. Every positive whole number you can think of are real numbers. That being said, you will notice again underneath our diagram that we have the integers, and you have the positive integers, the negative integers. So the question is, what are negative integers and what are positive integers? There are some whole numbers that are negative, and we call them negative integers. They are not fractions, they are not decimals, they are only negative, but at the same time whole. So those numbers that are whole but negative are regarded as negative integers, while the numbers that are not negative, that is numbers that are whole but positive, whole and positive rather, are called positive integers. That is the natural numbers, excluding 0 in this case. So if you put positive integers together with 0 and negative integers, some texts will recognize them as integers. Now please take note of what symbol, just in case you are solving a problem in mappings or functions of a real variable. Should you find this type of Z, it is referring to integers. Now, you will notice that integers being just above natural numbers are found under real numbers. This means that every natural number is an integer and every integer is a real number. So all natural numbers are real numbers. All integers are real numbers. So now on integers come directly under rational numbers. And rational numbers, please take note, are numbers that can be expressed as a ratio of two integers. So any number that can be expressed as a ratio of two integers is a rational number. And that rational numbers are denoted by this type of Q. So rational numbers, because they are found under real numbers, are real numbers. So 4 over 3, 3 over 4 are numbers that are expressed as ratios. All those numbers that can be expressed as ratios are real numbers. Then we have irrational numbers, numbers that cannot be expressed as a ratio of two integers. One of them is the square root of 2. So you can look that up after this class. The proof is a popular proof on the internet. The square root of 2 is an irrational number because it cannot be expressed as a ratio of A to B. Now, irrational numbers are real numbers. Rational numbers are real numbers, okay? So, that being said, let us now examine this question. Looking at our question number 1, let's come over here. So, for question number 1, solution. For you to know the domain, all you have to do is to examine the function. So the function given to us is f of x equals x squared plus 1. This function given to us is a polynomial function. Once you are given a polynomial function, students in your exam, please take note. Polynomial function, the domain of any polynomial function is the real number system. So every number that is real will satisfy this function. For that reason, if you are given a polynomial function in your exam to determine the domain, all you have to say is that the domain of the function f or the mapping f is R. Okay? Now, guys, what does R mean? It refers to real numbers. So when asked that question in your exam to determine the domain of the mapping there, looking at the function, this function is a polynomial function, and take it today from me that the domain of polynomial functions are real numbers. So the answer to that question 1A is R. R is the set of all real numbers, and for a polynomial function, R is the largest domain as demanded there. Okay? Then let's go to number 1B. Let's go to question number 1B. So in question number 1B, the function given to us is g of x equals 3x squared, 3x plus 2 all over x squared minus 1. The question is, guys, what is the domain of a rational function? This function is a quotient. It is a quotient of two polynomials, 3x plus 1, 3x plus 2 rather, over x squared minus 1. The polynomial, a ratio of two polynomials will give you a rational function, provided the denominator is not equal to 0. Because when the denominator is equal to 0, it means that that function will be undefined. So, when you are given a rational function, guys, please take note. A rational function, a function of this nature, a ratio of two polynomials, has a domain R, excluding the a case where the denominator is equal to 0. So how would you find this? How would you solve this problem? The first thing you would do is to accommodate this. Please do this in your exam. So you would start with catering for the case, or looking at the case for which this function will be undefined. So at one point you would simply say, recall that for g of x to be undefined, recall that for g of x to be undefined, x squared, the denominator must be x squared minus 1 must be equal to 0. So if x squared is equal to x squared minus 1 is equal to 0, it means x is equal to plus 1. And x will be equal to plus or minus 1. The square root of 1 is plus or minus 1, meaning that this can be written in set form as minus 1 plus 1. Minus 1 and 1. Okay? So once you know that this function will be undefined at this point, exclude them from the real number system, and that will give you your domain. So once you do this, this will help you to identify the values for which this function is undefined. And those values for which this function is undefined are the values for which the denominator will be equal to 0. And when the denominator is equal to 0, this function will be undefined. So you have to start this question with getting the denominator, the value of the denominator for which it will be 0. And once you do that, you will now say, therefore, the domain of G rather is R, the set of all real numbers, minus 1, 1. This set. Okay? So what is the domain, guys, of B? The domain of B is the set of all real numbers excluding minus 1 and 1. That will be the largest domain. So apart from minus 1 and 1, this function is defined on the real number system. Okay? Now, that being said, let's go to question C. So I'm going to come over here. The same thing that applies to question B is what applies to question C. So what would you say? F of x is equal to 2 plus x all over 2 minus x. This again is a rational function. I hope you can see what I'm discussing on the board. So this again is a rational function. So the first thing you would have to do is to find the value of x for which this rational function will be undefined. And what you simply do is to start with saying that f of x is undefined at 2x minus 2 minus x equals 0. So if 2 minus x is equal to 0, then it implies that x will be equal to 2. Okay? This means that at x equals 2, this function f of x is undefined. And if you are talking about the domain is the largest admissible set. It is the largest admissible set of the independent variable. It is the largest admissible set of values that x can assume. So all you have to do is to exclude this value that makes the function 0 from that largest admissible set. So what then will be your domain? You now say, therefore, the domain of f is R, the set of all real numbers, minus the set that contains 2, the singleton. Is it clear? So please, if you are given this in your exam, approach it from this angle. That will give you the correct answer. Now let's go to D. In D, there is a function h of x, guys, equals 1 plus x all over x squared minus x plus, minus 6. So you are asked again to find the domain of definition of that function. The same thing again applies. This function is a rational function. In this case, I'm going to bring the solution here. I'm going to bring the solution here. So let's tackle that problem over here. Let's tackle the problem here. Okay? So what are we going to do? Your guess may be as good as right. So notice that for us to solve that problem, we must start with obtaining the values of x for which the denominator of that function, or for which the function will become 0. Okay? So that is what we have to do. So I'm going to start for this function. Let's bring the function over here. Question D, 1D. H of x is equal to 1 plus x all over x squared minus x minus 6. Please take note, guys. You will be asked in your exam, or might be asked in your exam, or could be asked in your exam to obtain the domain of functions. So what we are learning from this problem 1 is how to determine the domain of functions. Okay? So please go through the procedure. Please learn the procedure. It is as simple as that. You will be asked, you might be asked, you could be asked. So far so good. There is no question. Uforo, I'm seeing you. Thank you very much for joining the class. Excellence, I'm seeing you. You are well acknowledged. Thank you for joining the class. Endurance, thank you. Patience, I can see you. Mary Ben, Ifyok, Akman, thank you all for joining the class. Please, as you get into the class, do this particular channel a favor by smashing the like on the video. So click the like button. Thank you very much. Now, let's continue. So what I'm going to do for this problem, or in this problem, is to start with obtaining, equating the denominator to 0. So why am I equating my denominator to 0? It is simply because I want to know the values of x for which this function, the whole function h of x, will be undefined. Notice something about my denominator. My denominator is a quadratic equation. Okay, my denominator is a quadratic expression. So equating it to 0 means that it can be solved as a quadratic equation. So solving the quadratic equation, the solution to this quadratic equation can be obtained using the almighty formula or the quadratic formula. So that will be minus b, and your b is the coefficient of x. So it is minus 1. So minus b would mean, recall, okay, let's simply put minus b plus or minus b squared of b squared minus 4ac all over 2a. This is your quadratic formula. So using it on this particular problem, our a is minus 1, is 1, our b, so a is 1, b is minus 1, and our c is minus 6. So you will have minus b, which is minus 1, plus or minus square root of b squared, which is minus 1 squared, minus 4 times a, 1 times c, which is minus 6, okay? And that will result in 2 times 1 up in the denominator. So when you do that, you end up having minus 1 times 1, minus 1 gives you 1, okay? Am I seeing Prosper there? Prosper, if you are there, welcome. Welcome. I knew you were the first person I saw. Okay? So welcome to the class, Prosper. You are duly acknowledged. Thank you very much for your continuous support. So this would be the square root of 1 minus 1 squared plus 24, and that will give you over 2. So this will give you 1 plus or minus square root of 25 all over 2, implying that you end up having 1 plus 5 over 2 or 1 minus 5 over 2. Okay? So that is you trying to obtain the value of x, or the values of x for which the function h of x is equal to 0. So when you do that, you would end up having 6 over 2, which is 3, or minus 4 over 2, which is minus 2. So once you do that, you now know that the values of x for which this function h of x is undefined is 3 and minus 2. So once you do that, the question will now be, what then is the domain? What then is the domain of the mapping? What then is the domain of the mapping, guys? The domain will now be the set of all real numbers. Okay? So the set of all real numbers, excluding that, excluding 3 and minus 2, will now be the domain. So I would say, therefore, the domain of h is the set of all real numbers r minus the set that contains 3 and minus 2. And that answers your question. Okay? Now, I would love you to get this one done. So get this problem done and send your comments to me through the comment section, or send it to the email address you find on my YouTube channel, our YouTube email address. Okay? So please get that last one done, and let's move on to question number 2. So let's move on to question number 2. Please do well to ask your questions. If you don't understand anything, do well to ask your questions. So let's go to question 2 in today's class. Let's go to question 2. So in question 2, we shall be looking at another problem. Okay? We shall be looking at another problem. So let's see. Let's see. So question 2 says, determine determine the range of each of the following mappings. Determine the range of each of the following mappings. Okay, so the first mapping here is f from x into 3x minus 4. The second mapping is h from x into 5x minus 2. The third mapping is g from x into 1 minus x all over 1 plus x. The third mapping, or the fourth mapping, is f from x into x over 3 minus x. So in our first question, what we did was to obtain the domain. But in this second question, what we are doing is to obtain the range. So that is the difference. So now that you know how to obtain the domain, as we've seen in the first question, how do we obtain the range? So I'm going to start with writing solution. Okay? Solution. So I'm going to start with question 2a. How do we determine the range of f? So we are given f from x into 3x minus 4. Remember that this can be written as f of x equals 3x minus 4. Okay? So, now, all you have to do is know the domain of this function. What is the domain of this function? The domain of this function, as we've seen earlier on, the domain of f of x, or f rather, or f of x, whichever one you want to write, the domain of f is R. Since the domain of f is R, any real number you put into this function to replace x will produce an overall result. Now, think of any real number imaginable. You will notice that when you supply this function f of x, a real number, the result you will get for f of x, after supply, if you supply this function a value of x from the real number system, provided it is a polynomial function, the range will return a polynomial function. For this particular the range will return a real number. So since the domain of f is real and the function f is a polynomial, the range of f is R. So the range of this function would also be real. Okay? So if I put in a real number as -1 is an integer and it is also real. If you put in -1 to replace x, -1 times 3 will give you -3. -3 minus 4 will give you -7, and -7 is an integer. What are integers? They are real. They are real numbers. If you put in a fraction like 4/3 to replace x, 4/3 times this 3 will give you 4. 4 minus 4 will give you 0. And what is 0? 0 is a real number. So think of any value of x chosen or selected from the real number system and impute same into this function. If you do that, the resulting value of f of x will also be a real number. So the range of this function given to you to determine is the real number system. Now, for b, let's observe b. B will likewise be a real number system. So you were told h from x into 5x minus 2 is a function or a mapping. Now this can be written as h of x is equal to 5x minus 2. Okay? So if h of x is equal to 5x minus 2, look at it carefully. It is a linear function, otherwise known as a polynomial function. It is also a polynomial function. Now, what you should know about this is that the polynomial function has its domain to be real. Therefore, since D, the domain of H is real, that is D is equal to R, then the range R is also real, and also real. That is, R is equal to R is our range. Okay, so the domain of this, the range of this function is also the set of all real numbers. Now, please take note. How do we know? Why do we know it is the set of all real numbers? Think of any real number that you can put into this function to replace x. If you think of any real number, think of them whether decimal or fractional numbers or whole numbers that are real numbers. If you put in this function a real number, the result of h of x would also be real. So all real numbers would make up the range of this function. Now, let's go over to the next question. That is question C. Let's go to question C. Let's attempt question C. Now you will notice that question C is a rational function. Question C is a rational function. Okay? So, what will be the range of this function? What will be the range of this function? Now, being a rational function, remember our domain referred to all the values of x that are real was our domain. Now, how do you determine the range of this particular function? So, what is the function given to us in C? The function given to us is g of x equals 1 minus x all over 1 plus x. Okay? So, apart from the zeros of this, apart from the values of x that will make this function undefined, what was our domain? Our domain was all real numbers excluding, for this particular function, it will be the set of all real numbers excluding x equals minus 1. So, it will be all real numbers. The domain of this function will be all real numbers excluding minus 1. Now, take note, why is it minus 1? The function g rather, the function g is undefined. The function g will be undefined at x 1 plus x equals 0. And when 1 plus x is equal to 0, it means that x will be equal to minus 1. So at x equals minus 1, this function will be undefined. As such, the domain of this function is the set of all real numbers minus the set that contains minus 1. So if you put in minus 1 here, the domain of this function will cease to exist. At minus 1, it ceases to exist. So apart from minus 1, every real number will satisfy this. Now, if you want to obtain the range, think of every real number apart from minus 1. If you put in any real number apart from minus 1 into this function, the result will give you a real number. Okay? So, if you put in any real number apart from minus 1, the result will give you a real number. So, the range of this function, we say the range of R, or the range of the function g, rather, the range of g is R. Okay? The range of g will be R. Now, because we know now that the domain contains all numbers apart from minus 1. Okay? So the range must not necessarily accommodate minus 1. Since we know that it is all real numbers excluding minus 1, the range can assume every real number from this domain. Okay? So if you put in any real number from this domain into the function to replace x, the result you will get, for instance, pick 2 and put 2 as x. 1 plus 2 is what you have in your denominator, giving you 3, and 1 minus 2 will give you minus 1 all over 3. Okay? So, if you keep selecting numbers from this domain, the set of all real numbers excluding minus 1, your result may even be minus 1. So, you don't state, it is possible to put values of x here, and you get your result as minus 1. And if you had made the mistake of saying your range is the set of all real numbers excluding minus 1, that would be wrong for the range, but correct for the domain. Okay? So, it is possible to put all the values you have in R, in D, which is R minus 1, It is possible to put in all the values and get one of such results giving you -1. So it will be wrong of you to say your range is a set of all real numbers excluding -1, just like your domain. Your range will be the set of all real numbers. Please take note. Now, the same thing applies to D. The same thing applies to question D, that is 2D. Now, I'm not going to go into the intricacies. Let's just repeat what we've done. How would you tell the range of this function 3 minus x? Now, the domain of the function will give you the clue. The domain of this function will be the set of all real numbers excluding, what do you call it? 3. Now, why would it exclude 3? This function will cease to exist when 3 minus x is equal to 0. And if 3 minus x is equal to 0, it means that x is equal to 3. So, when x is equal to 3, if you put 3 here, you would end up having 3 as x all over 3 minus 3, which is 3 over 0. And any number, any fraction whose denominator is 0 is an undefined fraction. So, once you put 3 minus 3 and get 0, it means that 3 makes this fraction undefined. Okay? Okay. Prosper. Okay, let me get your first question. So Prosper is saying, sir, please, can you rewrite an example of a polynomial? Good, I will do that, Prosper. Then Prosper is also asking, guys, Prosper is asking, I told example A is, I thought example A, probably that's what you wanted to write. I thought example A is a binomial expression. Example A. What example are you really referring to, Prosper? Example 1A or example 2A? 1A. Okay? 1A is a binomial function or binomial expression. No. I will explain what a binomial expression is. I will explain what a binomial expression is. It's not a binomial expression. Okay? It's a polynomial expression. So I'm going to put you through quickly your two questions in one. I'm going to explain them right away. So let me conclude with this problem. Please take note again, guys. Remember, this class is an interactive class, and in this class we are all here to learn. So please take note. I won't be teaching or explaining or solving problems without giving you some to solve. Now, please go through what I have done so far. I have done A, exercise 2A, exercise 2B, 2C, and that should tell you how to go about solving D and E. But I'm going to be solving 2D and leaving you with E to get done. Please, when you get your problem solved, do reach out to me by dropping your comment in the comment section or through my email address. Okay? I'll be expecting to see that. Now, let me attend to this problem and quickly go to answering Prosper's question. Okay, you're asking do example 2A. Okay, you said example 2A. Now, please take note, Prosper. What we call a binomial expression. A binomial expression is an expression that contains two terms. Okay? Any two-termed expression will make a binomial expression. So, in that regard, you are right. But the context of, that is not the context of this question. That's what I would say. That is not the context of this question. Now, when we say you are to expand a binomial expression is a two-termed expression, meaning that anything here could be your A and anything could be your B. Meaning that if you had x squared, just like you had x squared plus 1 is a binomial expression. Okay, in that context, in the context of what you have just asked, this makes for a binomial expression. Provided I can have two partitions that make up two terms, that can make a binomial expression. But how do we expand these kind of expressions that are two-termed expressions, when they carry powers that are larger than 2 or even 2? That's where the binomial expansion, the idea of the binomial expansion or the binomial theorem comes in. Okay? So, in this particular case, you will notice whether it is a binomial expression because it has two terms, that does not stop it from being a polynomial expression. So, I wouldn't want to jump hastily into concluding that every binomial expansion is a polynomial function. You will be wrong. Every binomial expansion, let me give you an example. So what you should be asking me rather is, sir, what is a polynomial? What is a polynomial? Let's put it that way. Meaning that, let me show you an example. This is a binomial expansion, or expression rather. If I have x raised to the power 1 over 3 plus 1, this is a binomial expression because it is a two-termed expression. And if I have a problem involving or requiring me to expand this to the power of 4, it will make for a binomial expansion. Okay? But take note of one thing, Prosper. You should know that this one here also is a binomial expression, and raising it to a power would call for the use of the binomial expansion technique. Now, what is the difference? The reason why I'm telling you not to conclude that every binomial expression is a polynomial function is that whereas number 2, the function inside the bracket in number 2 is a polynomial expression, the function inside the bracket in number 1, the first bracket here, is not a polynomial. It is not a polynomial expression. So the question you should be asking me, Prosper, is, sir, what is a polynomial expression? And that my answer goes to all of you watching this video live. Please, guys, take note. A polynomial is defined as the sum of separate terms in a given variable having positive, positive integer powers. Meaning that a binomial expression cannot have a variable carrying a negative power. It cannot have a variable carrying a fractional or decimal power. That is why this one here, although x raised to the power 1 over 3 plus 1 is a binomial expression, it is not a polynomial expression. You see it? But this one here below, x squared plus 1, by the definition I've just given you, is a polynomial expression or a polynomial. Why is it a polynomial? The power of the variable x here is positive. Okay? So, and it is the sum of separate terms. Okay? So polynomials are sums of separate terms in a particular variable or variables with positive and non-fractional, non-decimal powers. Okay? So please take note of that. Now, I believe I've answered your question. Okay, so you've just said, but sir, example 2a is 3x minus 4. 3x minus 4 is also this is a two-term expression. So going by the fact that it is a two-term expression, what are the two terms? One term is 3x, the other one is 4. This one here is 5x and the other one is 2. These two expressions are binomial expressions because they have two terms. But I am telling you that even as it is a binomial expression, it qualifies to be a polynomial. Why is it a polynomial? You will notice that 3x minus 4 can be written as 3x raised to the power 1 minus 4. And 1 is a positive integer. What then is the definition of a polynomial? It is the sum of separate terms of positive, non-fractional, non-decimal powers in a given variable. So x is the given variable, 1 is a positive, non-fractional, non-decimal power. So even as this expression is a binomial expression, it is also a polynomial. Now, why I wouldn't want you to conclude that all polynomial expressions are binomial, or all binomial expressions rather are polynomial, is simply because if a binomial expression has a decimal power or a fractional power, it is possible for a binomial expression to have a fractional power. This binomial expression is not a polynomial because polynomials do not have fractional powers. Polynomials do not have decimal powers. So the reason why I am calling this a polynomial expression is because the power is actually positive and it is the sum of separate terms. So it still qualifies to be a binomial expansion. Okay, an expression. So I hope I've answered your question, Prosper. So okay, now let's conclude. So what will be the range here? The range of R will now be the range of this function f, rather. So we say the range of f is R. Now, let me explain again. Why is the range of x R, of f R? Please, the domain is R minus the singleton 3. The singleton that contains 3 does not mean the range must also be the set of all real numbers excluding the singleton that contains 3. No, it is possible for this to be the domain. This is the domain certainly, but the range will be all admissible values from the real number system. Simply because if you put values that are not 3 into this function, it is possible that in one occasion or on one occasion it could simplify to 3. So 3 being the only number excluded from your domain does not mean it must be excluded from your range. Okay? So please take note of the difference between the domain and the range. Now, that being said, in the absence of any other question, thank you, Prosper, thank you very much. Now, in the absence of any other question, let us quickly go to example 3. Let's go to question 3. Let's go to question 3. So, now, for question 3, we shall be looking at another problem I want you guys to take note of. I want you to take note of another problem that is very important and you might be meeting in your exam or in an assessment. So please take note of it. It is very, very important. So let's see what problem is there in example 3. So in example 3, we have the question that says given the mapping G x into 3 plus x all over 2x minus 1. The question says determine 1, or A rather, determine A, G of 0, B, G of 1, C, G of minus 1, D, G of 1 over 3, and E, determine G of minus 1 over 2. Now, please take note again, guys. Please take note. Okay, please take note, guys. I'll be solving this, and I'll be leaving this to you or for you to solve. Okay, so question D and E are for you to solve. So I'm going to be solving these. The reason for solving these problems is to show you how, remember, okay? So I'm going to show you how to solve this, and the remaining questions D and E from 3 are for you, okay? So you can call that a teacher's love. What else would a teacher give to a student if not problems, okay? So, problems that are tractable, mind you, problems that have solutions, just to brainstorm and get knowledge. So please, let's go over to solving that problem. So please come over here. Now the function 3a. So in 3a we were given the function g of x. I'm going to write my function g of x as this 2x minus 1. So all you have to do in question A, since we are asked to find g of 0 means put x as 0 into that function and simplify. So that will mean 3 plus when x is 0 all over 2 times 0 when x is 0 minus 1. So what would that give us? 3 plus 0 will give us 3. 2 times 0 is 0. 0 minus 1 will give us minus 1. So you end up having minus 3 as your result. It is that fast, it is that simple. So when you are asked a question like that, that giving g of x equals 3x plus 1 all over 2x minus 1, and you are asked to find the value of x at a given point, all you have to do is to substitute for that value into the function and it will give you a result when you simplify. So let's go to B. Now g of 1 is equal to 3 plus 1 all over 2 times 1 minus 1. And that will give us 4 in our numerator. All over 2 times 1 is 2. 2 minus 1 is 1. And 4 over 1 is 4. So, then finally, for C, we were asked to find g of minus 1. So g of minus 1 will mean putting in place of x, we shall be putting minus 1. So this will be all over 2 times minus 1 minus 1. And this would result in plus times minus is minus. So 3 times minus, minus times plus will give us minus. So that will be 3 minus 1 all over 2 times minus 1 will give us minus 2. And minus 1 comes here. So this will result in 3 minus 1, which is 2, all over minus 2 minus 1, which is minus 3. So your result is the same as minus 2 over 3. Okay? Now, that being said, please, for this problem, okay, now I'm told there's another question. Yes, prosper, prosper, prosper. I like it when you ask questions. So what questions do we have here? Sir, are we saying, I hope guys you can actually learn from the questions of Prosper. Hilary, welcome. Blessing, you're welcome. I can see you guys. So what is Prosper asking? Prosper is asking that, sir, are you saying for a fractional expression the denominator must be equal to 0 for we to have our domain and the expression will be undefined? No, 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 no. I'm not saying that. What I'm saying is this. I started with telling you that what is called the domain of definition for a function is a set of every admissible value of the independent variable. Okay? So it is just like saying what is the largest set of all independent variables that this function can assume. Now, if you think of all the independent variables that the values of the independent variable that the function can assume, that will constitute the domain of that function. So the domain of the function contains every value of x that can be assumed by the function. The domain of the function includes every value of x that can be assumed by the function. And the largest set that contains all values of x, such as this, is the real numbers. But you must take note of this. Before you conclude that it is the real number is your domain, you must check out for the case, the value of x that will make that function undefined. You must check out for that value. How do you check out for the value that make your function undefined? You would have to equate the denominator of that rational function to 0 and obtain that value of x. That value of x has to be removed from what you call your domain, because if you include it, it means you are telling us that even when the function is undefined, the value that makes it undefined is still in the domain. So the domain of definition includes every admissible value that can be assumed by your independent variable, excluding the value that makes it undefined. Okay? So in finding the domain of a rational function, it will contain every value that can be assumed by your real number, by your function, excluding the value that makes it undefined. Olga, Mary Grace, welcome to the class. Thank you very much for your support. Thank you. Welcome to the class. So I hope that is understood, Prosper. Every value of x for a rational function, excluding the value of x that makes it undefined, is a value in will make up your domain. Okay, so that is why I started for every rational function with excluding that number, finding that number, that value of x that makes the fraction undefined. Okay, so that is the proper thing to say. So I hope that answers your question. I hope that answers your question. So when obtaining the domain of a rational function, guys, please start with identifying the value of x that makes it undefined, or the value of the independent variable that makes it undefined, and exclude it from the real number system if the real number system is your largest set. Okay? Now, please, I want you guys to get 3D done and 3E done. That will be your task. Get that done and send your comments to me in the comment section. I'll be seeing that when I check. Okay, let's go to question. Okay, now let's go to question let's go to question 4. But let me ask a question. Now, please tell me in the comment section, all of you watching the video live, look at the functions. Please, could you point, okay, so you can all see the functions. Now, tell me, somebody in the live section should tell me, what is the domain of this function? What is the domain, the largest domain of this function? G of x equals 3 plus x all over 2x minus 1. Who can tell me in the comment section what the largest domain of this function g is? Okay, so let me see your answer in the comment section. What is the largest domain of this function? G of x equals 3 plus x all over 2x minus 1. And some other person can also tell me why. If someone gives the answer, I want another person to give me the reason why it is so. So, let us quickly go to, while that is on, let's go to question 4. So please, could you put the camera here, okay? So let's go to question 4. Let's go to question 4 and see what we have there. So, in question 4, we have, question 4 says, given the mapping f from x into 7x minus 2, determine A, f of 2, B, f of minus 2, C, f of 1 over 2, D, f of A, E, f of A plus H, f of A plus H minus f of A. Now, let us quickly get this problem done. Let's get that problem done. So I'm going to solve this problem, question 4. Now remember, I asked a question, I had already asked a question. Somebody should tell me the domain of the function in example 3. What is the domain of that function? So, do I have any answer in the comment section? Not yet. So, while you figure that out, let's look at solving question 4. Now, for question 4, we have 4a, we are asked to find f of 2. So what would f of 2 be, guys? What would f of 2 be? Now, if you take note of the function, what we were given, f from x into 7x minus 2 implies that f of x is equal to 7x minus 2. Okay? So what you'll be doing, if this problem is given to you to find f of 2, is to put 2 in place of x in this function wherever you find it. So f of 2 will be equal to 7 times 2 minus 2. And that will give us what? So that will give us 7 times 2 is 14 minus 2. 14 minus 2 will give us 12. Okay? And that answers the question. It is as simple as that. Now, for B, let's go back to B. B requires that we find f of minus 2. So what we have to do is to put minus 2 into this function. So wherever we find x, we shall be putting minus 2. And that would mean 7 times minus 2 minus 2. And 7 times minus 2 will give you minus 14. Minus 14 minus 2 will give you minus 16. So that will be your result. Now, for C, if you are asked to find f of half, 1 over 2, it means in this case you will be putting 1 over 2 in place of x. So that would be 7 times 1 over 2 minus 2. And that will return 7 over 2 minus 2 over 1. So the LCM of 2 and 1, guys, the LCM of 2 and 1 is 2. So that will result in 2 being your LCM, and 2 in 2 is 1. 1 times 7 is 7. 1 goes into 2 to give you 2. 2 times 2 is 4. So that will return 7 minus 4, which is 3, all over 2, which can be written as 1 over 1 over 2. So when you put in half into the function, it will reduce to 1 whole number 1 over 2 when simplified. Okay? So, for this kind of problem, guys, all you have to do is to know what the problem is all about, make substitutions where necessary, and evaluate. Good. finally I have seen a solution to the question I asked. So I asked the question, guys, what is the domain of that function g of x into x 3x and 3 plus x all over 2x minus 3? And Prosper has just given me an answer. The answer is r minus, that is the real number system, excluding 1 over 2 when x is equal to 1 over 2, the singleton. You are very, very correct. So thank you very much, Prosper, for that answer. Thank you very much. I really appreciate that answer. So the answer, guys, when asked what the domain of this function is, it is the set of all real numbers excluding the value of x 1 over 2. When x is 1 over 2, this function becomes undefined because it will, x being 1 over 2 will make the denominator 0, and when the denominator is 0, the function will be undefined. So when the function is undefined, the domain, where it is undefined, the domain does not exist. Okay, at that point. So every other value of x in the real number system will make for the domain, excluding the one of 1 over 2. So Prosper, a big round of applause to you. You've done very well. Thank you very much. So now, similarly, I would want us quickly, being students in this live class, please, now that I have done 4A, 4B, 4C, and I'm going into 4D. Please, can somebody quickly tell me what f of A will be? What would f of A be? Now, what would f of A be? I want to see the quickest answer. Who will give me the quickest answer? F of A. What would f of A be? So what would f of A be? Okay? So f of A is you putting A. Let me see the quickest answer in the comment section. Somebody should give me the quickest answer possible. So I'm waiting, and I'm waiting. Somebody should give me the quickest answer right now. So what will f of A be? Going by what we've done. Of course, just to give you a clue, all you have to do is to put in A into the function and simplify if necessary. So what would f of A be? Now, I am going to go over to E. E demands that we find f of A plus h. So f of A plus h will be me putting A plus h in place of x in the function. So wherever I find x, I'm going to put A plus h. So that will be 7 in bracket A plus h minus 2. Yes, Prosper, what is your answer? 7A minus 2. A big thumbs up to you, Prosper. Thank you very much. So that is the correct answer. The answer is 7A minus 2, because at A, x becomes A in the function. So if you put A in place of x, you end up having 7A minus 2. So this will give us 7A plus 7h minus 2. Now guys, please take note. From functions, in tomorrow's class, we are beginning a new class. Our class on differentiation starts tomorrow. So the thumbnail will speak for itself tomorrow morning. Please take note. Tomorrow by 8 o'clock, our class on differentiation begins. Okay? So please, take note of that and try to join the class. Bring people to join this class. Something is happening here. Okay? We are cooking something here. Now, let's see what f of A plus h minus f of A will give us. So the quickest finger should give me an answer to that question. What will this result? F. What would be 4f? What would you get as a result? Now take note. We have gotten our result for f of A plus h to be 7A plus 7h minus 2. And we have gotten our result for f of A to be 7A minus 2. So what will subtracting f of A from f of A plus h give? Now, you are being prepared at this point on what we shall see in differentiation as the derivative of a function by first principle. So this is just a change. This describes a change in the function. So please, somebody, the quickest finger, Yes. Okay, Excellence has given me. Okay, you have a question. So, sir, in example 4E, can we factor out, I can't see what you wrote there. Can we factor out 7? Yes, you can factor out 7 already at this point, Excellence. You've already factored out 7. Now, the reason why you can leave your result in this manner, or you can leave it in this manner. Now, why did I choose to leave mine in this manner? In this manner, it is factorized and presentable. But I chose to expand mine in preparation for answering this question. Okay? So, this is what I'm going to do. Is there the quickest finger? Who is the quickest finger? So, what you are going to do, now that you know this to be this, you just bring 7a plus 7h minus 2 as your, this is for this, okay? So your f of a plus h was obtained to be 7a plus 7h minus 2. So you bring that here, okay? And you then bring what you got as f of a was in bracket 7a minus 2, okay? Now the bracket is not necessary here in the first term, but it is necessary for the second term because you have to expand. So if I remove this bracket, nothing will happen to my solution process. So this will result in 7a plus 7h minus 2 minus 7a. When you use minus to open up this bracket, minus 7a is what results. Minus times minus will give you plus 2. So you will notice that 7a minus 7a gives 0. And minus 2 plus 2 goes. So you will be left with 7h as your result. Okay? So, Prosper, thank you very much. So you could see we are on the right path. We got the same result. Thank you very much. So that's the correct answer. 7h. Now, that being said, let's go to question number 5. Let's go to question number 5, guys. Without waste of time, let's go to question number 5. So what is question number 5 saying? What is question number 5 saying, guys? Question number 5 is saying the mapping. Question 5 says the mapping f from x into x squared plus bx plus c. Okay, let me write this boldly. F x into x squared plus bx plus c is defined. The mapping is defined on the set of real numbers. Of course, that is R. Okay? It now says, given that f of 0 is equal to minus 3 and f of 1 is equal to 2, determine the values of B and C. I think if I remember correctly, we solved the problem similar to this in yesterday's class. And I told you in yesterday's class the idea. Now the question continues with saying, hence find f of minus 2 and f of 2. So now we solved something like that in yesterday's class, and I'm going to be cleaning this off to get that done. So let's quickly see. Now I want you to start thinking on how that problem should be solved. While you are thinking, I will be throwing my ideas at you on how to go about solving that problem. So what do you do? How do you approach that problem if you find such in your exam or if you find such in an assessment? What do you do? How do you go about solving that problem? Remember, if you attended yesterday's class, if you were in our live chat or live class yesterday, you will remember I told us that solving this problem requires the following. The step 1 for solving this problem is to obtain the values of B and C. How would you obtain the values of B and C? They've provided you with 2 things with which you can find the values of B and C. Now, the first step would be to substitute to find f of 0. F of 0 would give you are told f of 0 is equal to minus 3. So you will find f of 0 using this function given to you that will give you what you can call an equation 1. Okay? And you would use f of 1, which is equal to 2, given to you, to find, with this function, to find what you would end up calling an equation 2. Those two equations will be solved simultaneously, and when those two equations are solved simultaneously, it will give you the results for B and C. Okay? So that will be the algorithm, or that will be the steps to follow in solving that problem. So I'm going to put here solution. So how will my solution proceed? I'm going to start with f of x, we are told, is x squared plus bx plus c. So what next do I do? F of 0 will be equal to 0 squared plus b times 0 plus c. And f of 0 certainly, based on this, will be 0 squared is assumed to be 0. B times 0 is 0, so 0 plus c would give me c. But f of 0 is equal to minus 3. Therefore, c is equal to minus 3. Okay? So there will be no need for an equation there because I've already obtained the value of c. Now, I will now go over to f of 1. F of 1 we are told is equal to 2. So f of 1 using the function given to us will be equal to 1 squared when x is 1 plus b times 1 when x is 1 plus c. And that would amount to f of 1 being equal to 1 squared, which is 1, plus b times 1, which is b, plus c. Now, f of 1 we are told is 2. Therefore, 1 plus b plus c will be equal to 2. But we have just obtained the value of c to be minus 3. So we can now put b, but b is equal to, c rather, is equal to minus 3. Therefore, we can say 1 plus b plus minus 3, which is c, will be equal to 2. So if you make b the subject of formula, 1 goes over to become minus 1, and minus 3 goes over to become plus 3. So 2 minus 1 is 1, 1 plus 3 is 4. So it means that b is 4 and c is minus 3. Now, once you have obtained that, you will now rewrite that function. You can now say in particular, f of x is now equal to x squared plus what we now know b to be. B is 4. So I'm going to put 4x plus c, and c is what? Minus 3. So I'm going to put minus 3 here. Now, based on this function, you can now obtain what you were asked to obtain. F of minus 2. You can now say, therefore, based on this function, f of minus 2 will be minus 2 squared plus 4 times minus 2 minus 3. And that will result in 4. Minus 2 squared is 4. Minus 2 times 4 will give us minus 8. So it's minus 8 minus 3. So 4 minus 8 minus 3 is the same as 4 minus 11. And 4 minus 11 will give you negative 7. Okay? Now if you come over to f of 2, which you were also asked to find, the routine is similar. So you only do 2 squared when x is 2 plus 4 times 2 minus 3. And that would amount to 2 squared, which is 4, plus 4 times 2, which is 8, minus 3. 8 minus 3 is 5. 5 plus 4 is 9. So the result is 9. Okay? So, that's nice. That's nice. Very, very nice. Prosper is really active in this class. He has gotten the solution to that problem already, even before we got there. So that is very, very nice. Prosper, please keep it up. I want to see other students watching this video live, being present in this live class. I want to see you as active as Prosper. I don't want to see Prosper alone, guys. I want to see, I'm aware there are so many persons here watching the live class. Please be as active as Prosper. Be as active as Prosper. Prosper is very active in the class, answering questions. I don't want you to stay silent in the class, please don't stay silent. It is a learning class, and in a learning class, people ask questions. In a learning class, people interact. I don't want to be the only one talking. I don't want to be the only one doing stuff on the board. Please ask questions. Prosper, thank you for your questions and your time. I want others to be like Prosper instead of staying silent in the class. Now let's go back to question 6. Let's go back to question 6. So, question 6 says the mapping f from x into ax squared plus bx plus c defined on the set of real numbers is such that f of 0 is equal to minus 4. F of 0 is equal to minus 4, f of 1 is equal to 1, and f of minus 1 is equal to minus 5. The question says find A, B, and C. Okay? Okay. So find A, B, and C. Now, so that is question 6, guys. That's question 6. And I want us to do it together. Let's brainstorm. Now, so question 6 gives this problem. The mapping of x into ax squared plus bx plus c defined on the set of real numbers is such that you will now see that this confirms what I've been telling you all along, that for polynomial functions, the set of real numbers is the domain. Now, the mapping of f of x into that defined on the set of real numbers is such that f of 0 is equal to minus 4, f of 1 is equal to 1, f of minus 1 is equal to minus 5. Now we are asked to find A, B, and C. So I'm going to start my solution here. What do I do? Guys, all you have to do is to start with writing the function as f of x equals ax squared plus bx plus c. Now, we want to find A, B, and C. So what I'm going to do here is to start with f of 0. We are told f of 0 is minus 4. I'm going to use the function to get f of 0. So I'm going to say f of 0 will be equal to a times 0 squared plus b times 0 plus c. And when I do that, I would equate that to minus 4 because f of 0 is minus 4. So it means that this would imply that 0 squared is 0, 0 times a is 0. Okay, so we are taking 0 squared to be 0, and 0 times a will give us 0. So that goes. B times 0 is 0, so that goes. So it means that I know C to be minus 4. Okay? Now, in this case, you can even put that to be equation 1. You will now come over to f of 1. We are told f of 1 is equal to 1. Okay? So use f of 1 to do this. You will now put 1 in place of x in this particular equation, and when you do that, f of 1 will give us a times 1 squared plus b times 1 plus c. And that would mean a times 1 squared. 1 squared is 1, guys. So 1 times a will give you a. B times 1 is b, and you have c. So f of 1, remember, we were told is equal to 1. So since f of 1 is equal to 1, it means we have established a new equation that a plus b plus c is equal to 1. So I'm going to call this equation 2. Okay? Then you would now use finally f of minus 1. We are told f of minus 1 is equal to minus 5. So f of minus 1 from the equation is a times minus 1 squared plus b times minus 1 plus c. And that would amount to f of 1, f of minus 1 being minus 1 squared is 1, 1 times a is a, and then you have minus b plus c. Okay? So this will be equal to f of what f of minus 1 is. We are told f of minus 1 is minus 5. So I'm going to put minus 5 here. So it means that a minus b plus c is equal to minus 5, which will be our equation 3. Okay? Now, once you get that done, you can continue in this manner. But we know C to be minus 4. So I would say, but c equals minus 4, substitute for c equals minus 4 in equation 2 and 3. So we will now put the value of c equals minus 4 in equations 2 and 3. I hope you follow. So if you put the value of c into equations 2 and 3, what that will give you will be the next thing I'll be writing on the board. What that will give you will be the next thing I'll be writing on the board. So what would that be? That would mean having this. It will mean having, when you put c, which is minus 4, into equation 2, this equation will reduce to a plus b minus 4 equals 1. And that means we will end up having a new equation. 1 plus 4 will give us 5. So you will call this one equation 4. Okay? We are going to call that one equation 4. Are we good? So, now, if we proceed to putting or making substitution of c into equation 3, we are going to have a also, I'm going to say also a minus b minus 4, which is c, will be equal to minus 5. And that would imply that a minus b will be equal to minus 5 plus 4, and that will give us minus 1. Okay, so I'm going to call this equation 5. So solving equation 4 and 5 simultaneously gives this. So I'm going to bring equation 4 and 5 to be solved simultaneously. So what would that mean? By elimination method, I could simply eliminate b by adding equation 4 to equation 5. Once I get that done, adding equation 4 to equation 5 means that I'll end up having 2a. I'm going to have 2a because a plus a is 2a, b plus minus b will give us 0, and that will be 2a equals 5 plus minus 1, and 5 plus minus 1 is 4, meaning that a will be equal to 4 over 2, which is 2. So a is equal to 2. Now, substitute for a equals 2 in equation 4. If you do that, your a would end up giving you 2 plus b equals 5, meaning that if 2 plus b is equal to 5, then it follows that b has to be 5 minus 2. B will be equal to 3. So, what have we done? It means that our result finally will be a is equal to 2, b is equal to 3, and c, the one we obtained first, is equal to minus 4. And that solves that problem. Okay? Hope, good evening, welcome. Debbie, welcome. Thank you for joining the class. Please be active on the class. Be active, be very active. And by active, I mean stay focused in the class, ask questions, and solve problems. If I ask you questions, please do well to give me answers, or make an attempt to give me answers. Remember, unlike any other live class you have on the internet or you have on YouTube, this particular class is all about being interactiveness. Okay, so in this class I want my students to be interactive, ask me questions, respond to questions when asked by me. Okay, I don't want any silent student on this particular platform. Please endeavor to be active in the class. Now let's go to problem 7. I hope we still have time. Let's go to problem 7. Let's see if we have time. Yes, we have time. This class will be should be ending by 10 o'clock. So we have time a little bit. Now, let's see problem 7, guys. So in problem 7, we have the mapping. We are told the mapping G is defined. The mapping G is defined by the diagram below. Okay, the mapping G is defined by the diagram below. So what is the diagram? Let's see. The diagram given to us is this. There is a relation or a mapping G that takes elements from a set A and assigns to them elements from the set B, the codomain. So we have -2, -1, 1, and we have 0, and we have 3 rather. We have 3 and we have 0. Okay, so we have this, and we have this. Okay, so this is clearly a mapping. Now, what are we asked to find? So the mapping G is defined by the diagram below. The question says find a G of -2 plus G of -1. Now, I want the quickest finger to start solving this problem. So how do we find G of -2 added to G of -1? So start solving, guys. Start solving the quickest finger. Then C is G of -1 plus G of 1. Now, what attending this class would do for you or to you is that unconsciously or consciously, this particular class, attending this class on Q&A series would help you know how to solve problems. It will help you know how to interpret problems and how to approach them with a solution. So we are going to go into the next thing. Let's see the solution to this problem. So now, if I have the quickest finger who has given me a result, okay, most likely Prosper is seriously working on a solution. So Prosper is working on a solution. Please, guys, just like Prosper, start working on the solution to the problem I have given. Now, you will notice from that problem G of -2. Let's see what G of -2 is. Let's obtain what G of -1 is. And what else we have there? Let's also obtain G of 1. So what are these? Now, notice that G of -1, G of -2 is 3. So G of -2 is 3. G of -1, from that mapping, you will notice that G of -1 is 0. And G of 1 is also 0. Okay? Now, in A, you can now start with saying, since G of -2 is 3, G of -2 plus G of -1 would be 3, what G of -2 is, added to G of -1, which is 0, and your answer will be 3. And that solves that problem. B, G of -2 plus G of 1 would imply getting 3 added to 0, and that would also give you 3. Then finally, C requires that we find G of -1 added to G of 1, and this will be 0 plus 0, giving you 0, and that solves the problem. So the problem is not difficult. Now, let's go to problem 8. Let's go to problem 8. Okay, Prosper? Yes, Prosper has given a solution. A equals 3. Which one were you actually solving, Prosper? Okay. Yes, you are correct. So A is equal to 3. Thank you very much, Prosper. Thank you very much. Now let's go to problem 8. So the mapping, problem 8 says the mapping H is defined. The mapping H is defined by the arrow diagram below. By the arrow diagram below. Okay, so what's our arrow diagram below? We have this P, H into Q. We have this arrow diagram. We have -3, 2, and 5. And we have 16, 4, 7, and 8. Now, 3 is paired with -8. Sorry, this is -8. And we have 2 paired with 7. we have 5 paired with 16. Now guys, tell me please, can somebody tell me or give me an answer to this question I'm about to ask? Looking at this mapping, is this mapping onto? If we're in yesterday's class, quickly examine before we answer the question or ask go into the questions required. Okay, let me even put the question on the board. Let me put the question on the board. So there are some questions here based on that. So let me ask those questions. Let me put them on the board. Let me put the questions on the board. So the first question is this, guys. Number 1. The question says determine, that is I, 8I. 8IA. Question says determine the domain. Determine the domain of the mapping. Determine the domain of the mapping. B says, that is IB under 8, says determine the codomain of the mapping. Determine the codomain of the mapping. Then C says, IC says determine the range of the mapping. Determine the range of the mapping. Then comes II. II under 8 says is the mapping onto, is the mapping onto. And III says is the mapping 1 to 1. Is the mapping 1 to 1? So those are the questions asked. So let's examine them. Let's examine them quickly. Let's examine, is the mapping 1 to 1? So now, guys, looking at this particular mapping, to start with, to answer the first question under our solution, AIA is asking the domain, asking for the domain of the mapping. The domain of this mapping is clearly the set containing -3, 2, and 5. So I'm going to put here 8IA, D the domain, or P the domain. Let's use D to represent the domain. The domain will be what? -3, 2, and 5. This is the domain of that mapping, because it is the set that contains every admissible values of the independent variable. Now, IB, 8IB, what does it demand? What is the codomain of the mapping? The codomain, let's use C to represent our codomain. Our codomain, which is in this case, if you see it clearly, our domain D is P. Our codomain contains every element from which we are picking elements to be assigned with elements from the domain. So our codomain contains 16, 4, 7, and -8. And that is equal to Q. Okay? So our codomain is equal to Q. Then comes IC, guys. What is IC demanding? The range of the mapping. The range of the mapping contains images alone from the codomain. So if we call R our range, the only images you find in this codomain are 16, 7, and -8. And why is 4 not an image? It is because it was not assigned. So 16, 7, and -8 will form a set we call the range. The range is the set of all values that are images. Okay? So that is what you are going to get as 8IC. Now, going to 8II. 8II. Let's go back to 8II, guys. 8II is demanding that we answer the question, is the mapping onto? When is a mapping onto, guys? A mapping is onto when every element in the codomain is an image. Is every element in this codomain an image? No. The answer is a big no. Every element in this codomain, thank you very much, Prosper. Prosper is saying the mapping is not an onto mapping. Thank you very much. It is not onto because all the images are not having an element in the domain P as image. Okay, all the okay, but the mapping is one-to-one. Good. Thank you very much. I love your activity. I love how active you are on this platform or in this class, Prosper. I also love how active you are. Excellent. So thank you very much, both of you, for answering questions and for asking questions. Please, others should follow suit. Try to ask questions, try to answer questions, okay? Don't stay silent in the class. Okay? Now, 8II, the mapping is clearly what? The mapping is not onto, because not all elements in the codomain, are images. Okay? Then for III, the mapping is 1-to-1. Now, why is it 1-to-1? It is because no element in the domain is sharing an image. Every element in the domain has its own unique and distinct image from the domain of the mapping. Okay? Or the codomain of the mapping. So, that answers question 8. Now, let's go over to question 9. I hope we have time. Okay, so let's go over to question 9. Let's go back to question 9. Now, I still have a lot of questions. I have up to 40 questions here to use in this solver series. There are so many questions we have to solve, but we are going to take a pause on the solver series, on our solver series or Q&A series, so that we can go into another topic, the topic called differentiation. So we will be starting the topic called differentiation tomorrow. So we are going to take this most likely as our last question. It says the mapping, question 9 says the mapping F on the set A onto the set B is illustrated by the diagram. The diagram below. Full stop. Okay, so this is the arrow diagram for the mapping. -1, 1, 2, 17, 3, -1. And this is what you have, and this is what you have. So this mapping is both 1-to-1 and onto. And what do we call a mapping that is both 1-to-1 and onto? Who knows? We call it a bijective mapping. A bijective mapping. So this mapping is a bijective mapping. Now, the question says if it is given in addition, that f of x is equal to ax cubed plus b, then determine the values of A and B. Okay? So, what and how would you approach this question? It is simple. It is just, the question is just a little twist, has a little twist on what we have done earlier on. So, you will quickly do this. I would advise you do this. You just come to the mapping and take f of -1. F of -1 will give you -1. Okay? F of 1 will give you 3. And f of 2 will give you 17. So why are you bringing out these values? These values are coming straight from the mapping. This mapping, the f image of -1 is -1. The f image of 1 is 3. The f image of 2 is 17. So you bring them out. Why are you bringing out these values, guys? You are bringing out these values because you'll be needing them to get the values of A and B. To get the values of A and B. So all you have to do is this. Once you bring out this, you will now start with writing, but f of x is equal to ax cubed plus b. So if f of x is equal to ax cubed plus b, then f of minus 1, which is minus 1, will be equal to a minus 1 raised to the power 3 plus b. And that will give you minus a, because minus 1 raised to the power 3 is minus 1, and minus 1 times a will be minus a. This will be minus a plus b. And that implies that minus a plus b is equal to minus 1. So you can call this the equation 1. Now you only need 2 out of this to use. So you can go over to using the next one. Now the next one I could use is f of 1. Now what would f of 1 give me? It will give me a 1 raised to the power 3 plus b. And that would imply having a times 1. 1 raised to the power 3 is 1. So 1 times a will give you a. Then plus b. So it means that if f of 1 is equal to this, then a plus b is certainly equal to what f of 1 is equal to, which is 3. And I'm going to call this equation 2. So all you have to do is to solve equation 1 and 2. You will notice that you don't need f of 2. Now, whichever 2 you choose to use out of these 3 will give you the same result. So solve equation 1 and 2 simultaneously. Solve them simultaneously. Okay? Now, when you solve them simultaneously, you have a minus a plus b equals minus 1. And you have a plus b equals 3. So I could eliminate by adding the 2 equations. When you add, we would eliminate a. Minus a plus a will give you 0. B plus b will give you 2b. And minus 1 plus 3 will give you 2. So 2b will be equal to 2, meaning that b is equal to 1. Then when you get the value of b, you can now come over here and obtain the value of a. So what would the value of a be? You will substitute for b. You can say substitute for b equals 1 in equation 1. When you do that, that will give you minus a plus b, which is 1, equals minus 1. So it means that a, when brought over here to become positive, will be equal to 1, which stays here, plus this 1, which goes over to give you 2. So your result will be a equals 2 and b equals 1. So that, guys, that being said, please go over these problems we've solved in today's Q&A series on functions of a real variable. So this is our part 2 Q&A series on functions of a real variable. Now please take note, tomorrow we shall be beginning differentiation. Any class, after teaching any topic, in teaching a topic, I'll be using examples, okay? I'll be using examples, I'll be using illustration, just to show you or make you understand clearly what I'm teaching. But after teaching a particular topic, we are going to always have a Q&A series to that topic. In our Q&A series to that topic, we shall be looking at problems. It will be all about solving problems in that topic before we progress to the next topic. So that being said, guys, I really appreciate your support to the channel. I really appreciate your presence on the channel while having this live class. Please encourage your friends, encourage your colleagues to join the live class. They have so much to gain from attending this live class on our Q&A series and on our teaching series, okay? So please get them to subscribe to the channel, get them to like the video, get them to watch the video by you sharing the video, and make sure you drop your good comments, which could be questions or could be answers to the questions we've asked. So that being said, thank you very much for watching or staying tuned to this live class. God bless you. Good night.